Hello, my name is Alana Murphy, and this is use case 4 for Team 2. So first, we were asked to research the cause and effect relationships with big data implementation, and also to look at the 5 why questions used in constructing fishbone diagrams. And based on all that we learned, we constructed our own based on our current prescriptive and predictive analytics. So here's that fishbone diagram. As you can see, it's kind of hard to read. So I'm going to go to Mural's website where we created this, and just kind of go through each of these with you. So up top, we started with research and development. Is not invested in maintaining a sustainable life cycle. So these are going to be our root causes for our predictive. So the lack of research makes this process of obtaining resources damaging, and the lack of development of each battery prevents its reuse. And so we came to those from technology is not yet invented to recycle batteries for continued use indefinitely. Eventually they wear out and have to be scrapped for materials, and Tesla can't recycle batteries indefinitely. And then harsh chemicals are used and harmful byproducts are produced. The extraction process can cause this, and the process of producing batteries can cause this. So for our prescriptive, our root cause was identified as clean energy needs to be accepted by a larger population to reap the total benefits. So a mindset of upcycling and recycling needs to be weaved into societal culture, and more companies joining the clean energy revolution can improve infrastructure and make goals more achievable. And then the manufacturing process for automotive batteries is expensive. Replacing a battery is very costly, and people want to purchase new cars instead of replacing the battery. So, if it's broke, why don't I just buy a new one, which creates waste, which isn't good for sustainability, especially when mining these batteries can be quite expensive and harmful. Tesla has not succeeded in full implementation of their clean energy infrastructure yet. They're on the right page, but they haven't quite reached the end of the chapter. There's not currently enough clean energy infrastructure, and fossil fuels are sometimes used to provide power to charging stations. So they can be kind of counterintuitive. They might be using electricity, but another fossil fuel might be powering the electricity generated or in the building of each of those power stations. So getting back to our slideshow, we are then asked to identify the independent variables of both our prescriptive and predictive analytics. So our independent variables for prescriptive, they include Tesla's charging stations, the electric batteries in each car, the assembly line for each battery, and assembly of said charging stations. For predictive, these can include the materials comprising the batteries, design of the batteries, Tesla's production capabilities, and the mining process. And then we are asked to identify the dependent variables. So for prescriptive, that would be consumers' opinion, and their thoughts on EVs and Tesla as a company, the cost of assembly, competitors' efforts at sustainability, and the number of charging stations. For predictive, we have cost of extraction, outcome of research on methods for extraction, the environmental impact of battery development, and the environmental impact of discarding old batteries. And then finally, we are asked to look at our analytics models and see, based on this root cause analysis, if we would discard or continue to improve upon models that we've already created. And here we had a play on word to recycle or discard, since we're about sustainability. So our first and only model was to identify ideal locations for charging stations. So we've been creating this model based on consumer data, just finding out based on marketing research which demographics based on income, social status, location, job position, and other factors, who's more likely to embrace EVs and where they are concentrated, so that we can find the perfect place to put these big charging stations. So in identifying the ideal location for charging stations, Tesla is creating a more data-driven approach to clean energy infrastructure. In placing these in ideal locations, we can better serve demographics already embracing the environmental impact of EVs. This being said, if they're already accepting it, they're actually going to use it. If there is any environmental impact from building these stations, their high use in high trafficked environments amongst demographics that would embrace them, it would profit the environment by the end. And with all this being said, we should keep this model. And that is all for use case 4. Thanks.